In this video, we'll see how to represent and compare ratios on coordinate plane. What is a ratio? Well, a ratio is a relationship between two numbers indicating how many times the first number relates to the second. Let's see an example for the ratio of stars to circles. So when we read it, we have to read the order in which the ratio has to be given. So if it says stars to circles, we have to create the ratio where the star is related to circle, or we can write it as a fraction, star to circle. So in the ratio, there are a few different ways we can write. We can write it as 3 to 4 ratio because there are 3 stars related to 4 circles. We can write it as a fraction, as 3 over 4, 3 stars to 4 circles. And we can write it as word phrase 3 to 4, 3 stars related to 4 circles. So 3 to 4 ratio form, 3 to 4 fractional form, and 3 to 4 as a word phrase. The sentence or the question, the way it's being asked, that is the order how it needs to be answered. For example, if I was to reverse the question and say, what is the ratio of circles to stars, then I would put 4 to 3, or 4 over 3 as a fraction, or 4 to 3 as a word phrase. So the sentence is telling you which order or what is the ratio looking like. So questions again can be different. I can say, what is the ratio of stars to the total number of shapes? 1, 2, 3 stars. 1, 2, 3, 4, 5, 6, 7 total number of shapes. So that could be, let's say, stars to shapes. Then that would be 3 to 7. So if I change the question, I have to be careful in which order or what is the ratio being asked. Proportions, the equality of two ratios. So if two ratios are equal to each other, they form a proportion. When two fractions are equal, equality of two ratios. In the proportion, the cross products are equal. So to compare fractions, we have a few different ways. We can use cross product, that's one of them. And if the cross products are equal, that creates a proportion. Let's see out of the two examples that I have, which one will be a proportion. So do the given ratios form a proportion? We can cross multiply what is called cross product, and if the cross products are equal, the fractions are equivalent and they form a proportion. So 6 multiplied by 2, one way multiplication. 4 and 3, the other cross multiplication. And then we have 12 equal 12. That is a proportion. In the proportion, we have two equal fractions, or the equality of two fractions. If we cross multiply the second example, 10 and 5, one way across, product means multiplication. 7 and 9, the other way across, product means multiplication. So 10 times 5, 7 times 9. If the cross products are equal, that's a proportion. If not, it's not. So we have 50 and we have 63. 50 does not equal 63, not a proportion. So the two ratios do not form a proportion, or the two ratios are just not equal to each other. They don't have the same decimal value as well. So let's say if I divide 5 by 7, 0.7, let's say, round it up, and then 9 divided by 10, 0.9, 0.7, 0.9. There are two different values, so they're not equivalent, and the ratios do not form a proportion. Let's see how that looks like on the coordinate plane. So do the two ratios form a proportion? We're going to follow a few steps to compare it through cross product to show the ratios on the coordinate plane and see how they look like. So first, I'm going to use the cross product to determine if the ratios form a proportion. We have cross 4 and 6, and the other way across 8 and 3. So multiplying 8 times 3 on one side, or 3 times 8, and multiplying 4 times 6 on the other side. 3 times 8, 24, equals 6 times 4, or 4 times 6, 24. So the cross products are equal. That means that the two ratios are in a proportion. They are equivalent fractions. So a few different vocabulary words used for the same concept. Changing to decimal value, 3/4, 0.75, that's our 3/4. We can simplify 6/8. If we simplify 6/8, we get 3/4, which is the same value. Or we can divide 6 by 8, which is 0.75, same decimal value. So by comparing, the fractions are equivalent. Two equivalent fractions create a proportion. And on the coordinate plane, I'm going to graph each ratio to see how they look like, or the lines or the steepness look like on coordinate plane. So we're going to start at the origin and then go rise, which means up or vertical, and run, which means horizontal or right. So I'm going to add on here. For the ratio, we need to have vertical count or vertical side of the rectangle, and then horizontal. So first ratio, I have 3/4. Starting at the origin, I am going to draw a rectangle 3 by 4. 3 vertical, 4 horizontal, complete 3 vertical, 4 horizontal. That is my rectangle 3 by 4. 3 by 4 ratio. And then I have 6/8, vertical 6, 1, 2, 3, 4, 5, 6, horizontally 8, 1, 2, 3, 4, 5, 6, 7, 8. Complete that rectangle. And the diagonal is the same line. So on the coordinate plane, the 3/8 and the 3/4 and the 6/8, so 3/4 will equal 6/8. They will have the same steepness, same diagonal connecting the vertices of the rectangles. Therefore, when we compare the two ratios, we can state that 3/4 equal to 6/8. To answer the question, we have, do the given ratios form a proportion? So the given ratios do form a proportion. Because the cross products are equal. So we checked the two fractions to be equal by cross product, and on the graph we have the same line. The graph shows one line. Let's see another example. Two new ratios, 4/5 and 1/3. First, we're going to use the cross product to determine if the ratios form a proportion. In cross product, we multiply 5 and 1 and 3 and 4 on the other side. So on one side we have the 5 multiplied by 1 across, on the other side the 3 and 4. So we have 12, and then 5 times 1 is 5. 12 does not equal to 5, so this is not the proportion. Because the cross products are not equal. To graph, we are going to represent the two ratios, 4/5 and 1/3, as rectangles. Starting from the origin, I need the rectangle 4 by 5, where 4 is the vertical distance and 5 is horizontal. 1, 2, 3, 4. 1, 2, 3, 4, 5. Complete that rectangle. Trace an accurate line from this corner. I can go 4 up again. 1, 2, 3, 4, cross 5, and complete another rectangle. Or just draw that extension from the origin through my vertex and extend to label where 4/5 is. 1/3, 1 vertical, 3 horizontal. 1 vertical, 3 horizontal. So I have to go from the origin, 1 vertical and 3 horizontal to complete my 1/3 ratio. From the origin, connect the diagonal, extend, and label 1/3. The steepness of the ratio 1/3 is lower, 4/5 is higher. So our fraction 1/3 is less than 4/5, or we can say 4/5 is higher, meaning greater than 1/3. So to compare, 4/5 is greater than 1/3. If I compare numbers by using the cross product, 5 times 1 here is 5, and 3 times 4 here is 12. 12 is greater than 5, so I have the same inequality symbol. 4/5 is greater than 1/3. So we have the confirmation that these given ratios do not represent the proportion. Or do not form a proportion, because the cross products are not equal. And the graph shows two different lines. Let's see another example. Do these two given ratios represent the proportion? 5/7 and 3/4. First, I'll use the cross product. 7 multiplied by 3, multiplying the numbers across, and 4 and 5, or 5 times 4. 20 and 21. Not equal. Not the proportion. So the two ratios do not form a proportion by using the cross product. To compare, first I'm going to use the coordinate plane, then I'm going to use the cross product for confirmation. So first ratio, 5/7. Vertical, 1, 2, 3, 4, 5. Horizontal, 7. 1, 2, 3, 4, 5, 6, 7. And complete the rectangle. Using the vertex on the opposite side of the origin, we trace a line, extend, label that is 5/7. 3/4, 3 vertical, 4 horizontal. Complete the rectangle. These two are very, very close in value. It appears at first glance that the diagonal will be exactly on the same line. However, to make the line more exact, I'm going to use the count of 3/4 one more time from this vertex, and I see how it is different from the previous one. So I have 1, 2, 3, 1, 2, 3, 4. Then I can see that my dot is slightly above the previous line. To make it even more accurate, I'll use the same count one more time. So from that dot, I'll go for each 3, 4 across. So from the dot, 1, 2, 3, 4 across. And that is going slightly higher because the value of the ratio is higher. We're going to see that confirmation in a second. So 3/4. 3/4 goes above 5/5. It means 3/4 is higher than 5/5. Or I can say 5/5 is lower. That means it's less than 3/4. So when I compare, 5/7 is less than 3/4. Let's see that as cross product. 7 times 3 is 21. 4 times 5 is 20. 20 is less than 21. Therefore, 5/7 is less than 3/4. Another way to confirm is to change to decimal value. 5 divided by 7, 0.71. 3 divided by 4, 0.75. 0.71 less than 0.75. To answer the given ratios, do the given ratios form a proportion? No, they do not form a proportion, so the given ratios do not form a proportion. Because the cross products are not equal. And the graph shows two different lines. I'll get you started on the next example, and then we'll check more together in class. Do the given ratios form a proportion? First, we are going to check through the cross product. So on one side you multiply 6 times 6, on the other 9 and 4, or 4 times 9. Multiply, multiply. If the two numbers are equal, it means that the two fractions are equal. It means that the ratios create the proportion. If not, then not. When you draw or graph the two ratios, 4 vertically and 6 horizontally will be the first ratio, 4/6, and then 6 vertically and 9 horizontally will be the second ratio, 6/9. If the ratios are in a proportion, then you will have one straight line. It means that the vertices will overlap onto the same line. If you compare, the two ratios will be in a proportion if the cross products are equal. Give it a try. We'll check it in class.